Right, cool. Today we will talk about interceptors versus middleware. So that's two common patterns that you can encounter when you write some web applications in Clojure. So the middleware will be if you use Ring, and then there is a different stack to use Pedestal. And in Pedestal, the idea is to use interceptors. It could be a bit confusing for the beginners what are those patterns are about. So today we'll try to cover the basics, and you can explore on your own after this. So let's start actually with a simple concept of high order functions in Clojure, and that will help us to understand middleware a little bit better. So I've got this definition of high order function from the Clojure docs, and it basically says that high order function is a function that either takes one or more functions as an argument, or it returns a function as a result. And here are two examples. So the first one will take f here as one of the arguments. So it now matches this first definition of high order function, and an extra argument x, and that will be our kind of value that we'll work on. And then the idea is to apply the function twice. So we can say that instead of applying f once, we do f on top of the result of first execution. So let's run this thing. And as you can see, now we can run this function apply twice. The first argument is a function itself. In this case, it's an increment. So like, increment of 1 will be 2. So we do, we'll apply increment twice on this base value based on this definition of a function. So the result will be 7, as you can see here. And then the other option is to do decrement of 5, and that will be 3. So that first example. The second one is the Clojure and returning the functions. So here we have a function called adder, and it takes an argument x, and then it actually returns a function. So that could be really confusing for the people coming into Clojure, that you can actually return a function from a function and then use that newly created function to call and get some new values. So adder here will return a new function, as we see here. That new function will expect a single argument a, and then here inside we have still access to that original value of x that we sent to the call of the adder function. So now we will sum those two together, x and a, and if we call this, and let's create a new function add 5. So we're using our adder function. 5 is the value, that basically x here, and the return will be a new function, but this add 5 will be still a function that will always add 5 to any value that we send to it. So we execute this, we now have a new function defined, and then if we call this thing, we'll have 105. And you'll see the pattern of the high order function when we jump into the middleware section. So let's go here. Ring was one of the earliest ideas in Clojure to build web applications, and it basically abstracted the complexities of the Java world when we have complex classes for the incoming requests, headers, and all that stuff, and then the describing the responses. So now with Ring, we stay in the Clojure ecosystem. The thing that we need to do to write our web application is actually to define a handler that will expect a Clojure map as input params, which will describe everything we have in the HTTP request. And then you do some processing in the handler, and then you provide a response map, which again is just Clojure map. And then that response map will be properly converted by Ring into something that Jetty understands, for example, so you can return an HTTP response from your web application with Jetty, for example. So that's the simple case. Then the handler will eventually include more complex things like routing. So we need to define for this particular, if you're path matching this particular pattern, we call this particular handler. If you have, like, for example, get endpoint, post endpoint, all of those is done in routing. So there was things like Clojure originally, then there was a shift towards more data-driven libraries like BD, and nowadays I would say Rated is the most popular and most like the library with most features in the routing world. So, but it works on top of Ring. But why do we need middleware, right? We actually don't need it, right? You can just have a handler that do everything for you. But if you think about that, at some point you need to extract some common functionality into a different layer. And one example could be logging your requests, right? So you can create a logging middleware that will log the incoming request, then pass the execution to the handler, and then get the result, maybe log something from the response as well, like the HTTP status that we have, or something like that. Maybe measure the time, or yeah, something like that. But one of examples, there are other things like reading the request body, right? Because by default, you're just getting your body as just input stream, and you need to read it. And also, it could be different logic based on the content type. So you need to understand, let's say a client says that it sends JSON body, you need to do one thing in your body processing, reading the JSON string, or it could be something else, as well as like reading the, like parsing the query params, parsing the form params, stuff like that. So there's tons of things that we actually don't need in the handler itself. We want it in a separate layer. And in Ring, that's called middleware. And basically the middleware is a function that will take our handler as an argument, and then it will return a new handler. And the handler, as we remember, is a function that gets the request and returns the response map. And as you can see here, we're getting the handler as an input for our middleware function. And then returning a new function, it still gets the request as the input param. And here, interesting thing that we can decorate it before and after. So we can like do some logic here. We get the access to the original request. Then once we've done something that we need, we actually calling the handler that we received and passing the same request inside. Or interestingly, we can extend something in request. So we can soak some additional data inside request. So our handler that's downstream the chain of the middleware will get the new values in the request. And right here, for example, when we do the JSON body middleware, we reading the body from the request, we parsing the JSON string, and we add it back to the request as a new key with a JSON body. And the other handlers can assume that if they are called after that original wrap JSON body middleware, they will now have access to a new key in the request with a nicely formatted Clojure data structure in the JSON body key. So that's how we define middleware, and then we have our final handler, just a single one here for simplicity. We don't actually do routing here. In real world example, you'll have some routing library for that. So what next? Yeah, and then we just build the application, And the only thing we need is to actually thread our handler into our middlewares. So as you can see, we're using threading macro. We have the handler as our final function call, let's say, and then we wrap it in JSON body, we wrap it in logging. So a useful trick, if you see the middleware chain, you actually think from bottom to the top. So if you imagine you have a request, put it right here in your mind, like request, and then it goes up the chain of the middleware. So the first will be wrap logging called, then the result of that will be passed to wrap JSON body, then back to handler. And then when we get the response map from the handler, it now goes down. So once we reached here, we have the response map here, and it goes down from this point. Let me remove this. All right, so if I evaluate the namespace, I have some examples for you. So let's say we, to simulate, we obviously don't do real HTTP requests here, but to simulate, I just provide a simple map that simulates some bits of the request Clojure map. So here in the body, I'm just passing the data JSON file, and I can open it, data JSON. It just has a single A to 1 like JSON map. Why that will work is because here in our simple wrap JSON body middleware, I'm just using slarp on the body request, and actually slarp works on files as well. So we'll just read my file. Let me call this and we can see the output. Here we go. We have a log line from our logging middleware. So it will be ping for the URI that I sent, and then we're logging the outgoing response status. Then we have the result. And as you can see, the body will have our JSON string because we generate it right here in our handler, and we're actually getting the value from the JSON body request. Right, so if you're interested to learn more about middleware, the best way is just to go and read the implementations of the default middleware available in Ring library itself. You'll get stuff like wrap params. You'll see the same pattern, basically a function that takes a handler, or it can take an additional options. That's the other case as well. And then inside we just use this param request function to work with form params if we have, or the query params. So let's say we have query params. It usually will be as a string, and then we use that string. We parse the params right here in the params map, and then we adding that back into our request. And then the other example could be this, wrap keyword params. By default, the params will be just plain strings, but this one will actually get those params, as you can see, update in request params key, and it will do the keyify params. So it will convert all the string keys into the keywords, so we can use them more conveniently in our handlers. So that's about it about Ring and middleware, and we're moving to pedestal interceptors. So in pedestal we have slightly different approach. One of the best ways to understand the interceptors is actually to read their documentation, and this is the main one. What is an interceptor? I'll just cover it briefly. So the difference is we don't manually wrap our handler in a like stack of functions as we done it with middleware. We define common functionality inside interceptors, and then the library itself will manage that pipeline and will be responsible for calling them in the order and checking that we don't get any exceptions and applying the logic. And there are two phases, right? One is enter and one is leave. So our request is wrapped inside a context map, and then we have a chain of interceptors. Original context map is passed through the chain of interceptors through the enter function, and then it reaches the end, like the final handler, which is a specific case of an interceptor. You just have like leave and enter, basically is the same thing there. And then on the way back, we go through the leave logic of each interceptor. So here it looks, you can see it much clearer, right? So we have the context map and then go through interceptor 1, enter, enter, enter to the final handler, and then the response map goes through the leave function. So what we can do here is actually in the context map, I think you have access to the interceptor stack, so you can do complex things like manipulating the order. So that's defined here as a dynamic queue. So it can, let's say, your interceptor can decide and add something in the queue on particular condition. But also, the difference is that as we don't manually chain those calls in code, it's more data driven. So you see definitions like this. You have enter, you have leave as a map, and then you need to wrap that into interceptor, which is a record. And then the library will manage it for you. And at the end, you will define routes in a way like this. And then let's say the post, and the post will, the method for the interceptor chain for post will look like this. We do the logging, we do the JSON body interceptor, and then the handler interceptor. Usually you will want to move those two in default interceptors, so they will run on top of all your routes, and then maybe have some specific interceptors for your handlers, like handler and maybe something else specific to that particular logic. Let's say we have most of our routes in the service doesn't require authentication, and then we have a protected section of our application that needs some kind of authentication. So we can wrap that in, wrap that part of the routes in a specific block in our table, routes table, and then define a common protected or admin interceptor to actually protect those routes, so we know that no one can access them without proper credentials. So let's say some examples. Again, same logic. We have simple login interceptor. On enter, it gets the context, it gets the URI from the request, it prints the request, and see here we don't actually need to call any functions or handlers. We just return the context map from the enter. On the leave, again, we'll get the context map, and now we're looking into the response key. We're getting the status and we're logging that. For the JSON body, this is a specific case of an interceptor when we don't care about the leave, because that's supposed to work only on the request. So we're getting the request from the context. We doing the same trick with getting the body. We're doing the slurp on that. We're getting the JSON data. We're parsing the JSON string to Clojure map, and then we're extending our context. We're adding the JSON body key inside the request, and that will be used by our final handler. Again, final handler, we don't need leave here. We just use enter because it's like a single leave element of our chain. And here in the context, we are returning the response map, and that will basically mean that we now handling we done the processing and we returning something. So it will trigger the leave, like the interceptors to be called with the leave function on the way back. So here we say we have the status 200, we're returning some kind of body, and that's it. So it's pretty similar to what we have in Ring, just different libraries right here. To test that, you can use this chain namespace from the interceptor.chain, and there is an execute, so you can create your initial context, and then we have this interceptors vector with like a pipeline of interceptors, and when we call this, all of those will be called as if we were processing a real HTTP request. Let me call this and we will see some results here. Again, similar, we have the logging for the request, we have the logging for the response, and then we have some value returned to us. So I think that's no surprise. Again, to learn more about interceptors and how you can build them, maybe some more complex things, I would just go and read the default interceptors available in Pedestal. So let's say example is this body params. The library has really nice documentation, so you can read the doc strings here. See, same pattern, we wrap that into intercepts to create the record, but actually we just pass the map. It has the name and the enter, and then here we're updating the context, we calling the parse content type, and here it gets the parser map, and there's actually a default parser map. If we go here, we see there is a parser added for each supported content type by default. I would say like application JSON will be one of the most popular, and then we have this custom JSON parser. You can go here, and somewhere you'll see that we're doing the read JSON on the input stream, and we're adding these JSON params inside our request. So our handler can use the JSON params keyword to get the body of our request. And actually interesting that I noticed that they use the Chariot API by default. The Chariot is a zero dependencies library in Clojure to do that JSON parsing. So I think it's one of the fastest options available, and it's also also doesn't use any Java library to do the heavy lifting. It's completely written in Clojure, I believe, from scratch. All right, so yeah, that's it. I hope that was useful, and I think you now can explore on your own, maybe build something in Ring, build something in Pedestal, and see how the interceptors and middleware can help us to build that common layer with the common functionality in Clojure. All right, that's it for me. As usual, please like and subscribe if you enjoyed the video. It really helps. Leave comments and give me ideas for the next videos. See you. Bye-bye.